Greetings everyone, and welcome to the next video on my lecture series on differential equations. In this video, I will show how to verify the solution to a system of linear first-order differential equations. So you can see that I've already written out our example. We're going to verify that the vector capital X is equal to column vector 1, 2 times e to the negative 5t. That is a solution to the system d dt onto xy is equal to the matrix 3, negative 4, comma 4, negative 7 onto column vector xy. Okay, so how do we do that? Well, we're first going to write out that our vector x is equal to, and then rather than leaving it in this sort of weird factor form, I'm actually just going to incorporate the e to the negative 5t within the column. And so we get e to the negative 5t and 2e to the negative 5t. That's just taking our original solution here and rewriting it a little bit. Now I'm going to find the derivative of it with respect to t. And so I'm going to get negative 5 e to the negative 5t and negative 10 e to the negative 5t. Now let's recall what verifying a solution actually means. What you do is you take your solution and you plug it back into the original equation and you get an identity. You get that the left-hand side is equal to the right-hand side in the same way that if, for example, I'm just doing a little sketch on over here on the right, that if you have the equation 2x plus 1 is equal to 7, and you solve that, then you find that x is equal to 3. The way to verify that is you rewrite the equation, 2 times 3 plus 1 is equal to 7, and you find that 7 equals 7, which is a check. So what we're going to do here is we're going to plug our solution back in, and we're going to get something similar to the 7 equals 7. We're going to get that the left-hand side equals the right-hand side, and that shows that we know what we're doing. Okay, so now that we've done this, we're now going to sub back into the system of DEs. And the system said that dt onto xy is equal to 3, negative 4, 4, and negative 7. Rewriting the y here a little bit onto xy. But we found that the derivative was negative 5 e to the negative 5t and negative 10 e to the negative 5t, just right here. That goes there. Equals 3, negative 4, 4, negative 7. And then our xy, as you recall, and I don't really know why my tablet did that. Let me just move that down a little bit because it's bugging me. We know that xy is e to the negative 5t and 2 e to the negative 5t. That's from our original statement of x, which is our solution. And so now we're just going to multiply it out the right-hand side. Remember how this works is you take the row and you multiply it onto the column. And then here we will get, oh, and I should mention before we do that, this is a 2 by 2, and this is a 2 by 1. And so our resulting vector here that we're going to get is a 2 by 1. Doesn't really look like 1 because the entries are kind of obnoxious, but this vector that I'm just writing here is 2 by 1. We're going to have 3 times e to the negative 5t minus, and then the negative 4 times the 2, that's going to give 8 e to the negative 5t. That's just a single entry. And then we're going to have the 4 times the negative 7, or sorry, the 4 and the negative 7 multiplying onto that column. And that gives us 4, oops, I forgot the t, 4 e to the negative 5t minus 14 e to the negative 5t. And of course, we can clean that up. These are all like terms, and so we get 3e to the negative 5t minus 8e to the negative 5t gives us negative 5e to the negative 5t, and 4e to the negative 5t minus 14e to the negative 5t gives us negative 10e to the negative 5t. And so the left-hand side that we see above, that doesn't really work because I've been using that for too much. But if you just take a look here at what we said the left-hand side was, we see that that's equal to the right-hand side, and that gives us our check. Now, a good question to ask is, how do we actually get the solution? We're going to be working on that in our next section, but I just wanted to do a little preview here, which is, where does the solution come from? We have that x is equal to 1, 2, on to e to the negative 5t. We also had that a is equal to the matrix 3, negative 4, 4, and negative 7. Now if we take a look at A, then the eigenvectors, or eigenvalues rather, and eigenvectors of A are, using our knowledge of linear algebra, we get that lambda 1 is equal to 1 with lowercase vector x1 is equal to 2, 1. And lambda 2 is equal to negative 5 with x2 is equal to 1, 2. And I think that you can easily see that our eigenvalue is the coefficient on t in our exponent, and the eigenvector, 1, 2, is what we're multiplying out front. Unfortunately, I guess that means that a little bit of review on eigenvectors and eigenvalues will probably come in handy before we tackle the next thing. I'm going to leave it to you to go take a look at your linear algebra notes.